Okay, so let's look at these three problems. And numbers 1 and 3 are the same kind of problem. So I'll do those first, and then we'll go back to this one, which has a little bit of extra in it. So we want to find dy dx. And notice that y is our top variable and x is our bottom variable. So we need an equation with y and x. So what we need to do is just compose these together first. That's the quickest way. So I can take this part right here, plug it in here for you, and notice that I'll have the square root of x squared plus 8. And now I'll be ready to take the derivative, and I apologize, I'm slow when trying to draw on the screen. All right, now before I take the derivative of this, let's rewrite. The square root is the 1/2 power. So this is the quantity x squared plus 8 raised to the 1/2 power. And now let's do the chain rule on it. So dy dx trying not to go into your writing there. Okay, so chain rule, 1/2 times the front lower our exponent by 1, and if we subtract 1 from 1/2, it's going to be negative 1/2. And then take the derivative of the inside of the parentheses, that's 2x. Now we just want to clean this up. I probably haven't given me enough room to clean it up, but let's notice 1/2 and 2 will cancel out. So let's just think of that as canceling out. My x has a positive exponent, so it's going to end up on the top. But this negative exponent is going to end up on the bottom. And 1/2 power, when it goes to the bottom, is really going to be the square root. So this is the square root of x squared plus 8. And there's my dy dx, or my derivative in terms of x. All right, now let's do the same thing to number 3, and I'll have a little bit of trouble with this allowing me to move down. All right, so I'll kind of have to do it above, I guess. All right, so we want to find dy dt. So notice y and t, so we're going to have to compose these together again. So I need to put this into both of these x's, which is going to make it t squared plus 5, that quantity squared, and then negative 6 times t squared plus 5. All right, so we could multiply all that out, but instead, let's just use the chain rule on it. And because it's not letting me go down, I'll have to go up here. So dy dt, let's see if I can kind of sneak it in there. All right, so 2 times the front. Lower the exponent, it's going to become t squared plus 5 to the first. And then derivative of the t squared plus 5, it's going to be 2t. And now the negative 6 is a constant that will just carry along as we do the derivative of the inside. We could have distributed it if we wanted to, but our derivative of t squared plus 5 is going to be 2t. And that's not a chain rule because this is all to the first power. And if we had distributed that, it had been negative 6t squared, which would have still given us negative 12t right here. And then negative 6 times 5 would have been negative 30, which will go away. So you don't really have to distribute it necessarily. Now, I'll leave it up to you to clean that up from there, and you'll have your dy dt, because you just need to multiply things out and add like terms. All right, now on number 2, however, we really need 3 different things. So dy du, you notice y and u, so we're just finding the derivative of just that. So that's dy du is just going to be 48 times front. Lower the exponent. And then du dx, well, let's just do that one. You'll notice u and x, so du, and I apologize that this looks so messy on here. It's going to be 15x squared. And 8x. Now, dy dx. Let's just do the same thing we did on the others. So first, y is going to be equal to this plugged in here. So really, 5x to the third plus 4x squared raised to the 48th power. So I've just taken all of that, put it right here. All right, and so now let's do this. 48 times the front, and I know it doesn't look like an exponent when I've written it with my pen like that, but that is the 48th power. Lower the exponent, it's 47. Take the derivative of the inside of the parentheses, that's 10x plus 4. Now we probably could clean this up a little bit. We'll leave that to you, for example. I know my 10x plus 4 is looking really sloppy, but a 2 will factor out a 10x plus 4. So we could multiply that 2 times that 48 out front, which would make it a 96, I believe. And we'd have 5x plus 2 in there. And they might need you to clean it up before you put it into my MATLAB.